thanks also to Jane for giving a bit of a negative view on recycling, because I wanted to talk about some positive aspects of recycling. But I think it's a very, because I'm coming from a very technical industrial material field and R&D development activities. So never actually looked at it from a food packaging and health aspect, because this is indeed a topic which is not really being addressed in the current developments of new plastics and new technologies. So that's really something that opened also my mind. Hello from Germany today. I'm actually talking from Bavaria, where we don't have such a big plastic pollution problem, but we definitely also care about reducing plastic pollution and about alternative solutions. And I'm, as Christoph already said, I'm Mateusz, and I'm very pleased also to fill the second half of this webinar with a bit of an economic perspective on the plastic pollution. And also give a bit of an insight on how circular economic approaches relate to this economic problem, and maybe provide solutions or a different view at least. But as Jane already mentioned, it's important to have this systemic view on this, and it's a very complex issue. So it's probably not enough to only look from one angle at this problem, and therefore I hope it's going to be a complementary impulse that I can give on my end. Well, first of all, as Christoph already introduced me a little bit, just some background about my activities and the consulting business that I started. Well, as he mentioned, I'm a very big sports fan, so that's why I did an MBA in sports management. But not only because of this, I was involved in a lot of R&D projects where we were developing solutions, new material solutions, mostly in the field of composite materials. And sports simply also turned out to be a very interesting testing field for these type of material solutions. So that's why it was also for me interesting to actually have an insight on how the economy behind selling then the product, and how it is to bring innovative material solutions into the market, how this works. And this was one motivation to add an MBA in sports management to this. But so my background is in materials, and that's also the background of my consulting activities, where we focus mainly on sustainable material and technology solutions, and with a strong focus now, of course, on circularity and circular product solutions, and basically help companies to develop more sustainable products or implement circularity principles in their business practices, or simply, which is the most exciting thing, explore more sustainable material solutions in a concrete product scenario. And as I mentioned, the focus is on composite materials and bio-based materials, because that's certainly the background that I have from my previous activities in R&D and industrial research. Yeah, plastic pollution and economic problem. That's the title that I will be using for this presentation. And why is there plastic pollution at all? Actually, that's the question. And one of the main problems, and this is also what Jane also already touched on, is because plastic is at the end of its life cycle, it's basically treated as waste without a value, or with too little of a value, so it's easy to discard it. And it becomes this waste because in a linear economy approach, at the end of the product cycle, it simply loses its economic potential that it has had in the beginning. And mainly because there is no market or no use for it. But today, I would like to show you that it doesn't have to be like this. If we redefine the value in the beginning of the product cycle, but also for the discarded material, and create new applications and markets, we can actually help to prevent the plastic pollution from the beginning. And this can be done very well by means of circular economic principles. Although, as Jay said, we have to be careful and look also at the application side in the end, and what are the consequences in various fields of applications. But in that sense, maybe plastic pollution, if you look at it from a more circular economic perspective, can become a circular economic opportunity. Or if you put it into other words, it may also be circular economy that may become a solution for plastic pollution. Yeah, but first, let's just have a feeling for what is this economic value that we're actually talking about. And I think I will start with some waste facts on our current plastic economy. In 2018, the European Union adopted a plastic strategy as one integral part of the Circular Economy Action Plan that you probably all know. And the intention was to put actually plastic into a circular logic, because already then, it has been already realized that actually the throwing away plastics is not only causing pollution problems, but also wastes an economic opportunity. So one of these drivers behind it is actually also the loss of economic value, and that's why some of the goals and aims, and now referring to plastic packaging, are, for instance, to achieve a packaging recycling rate of around 55% by 2030, or recycle at least of 65% of municipal waste by 2035, or and landfill less than 10% of the waste. That's very, very ambitious targets, especially if you look at the current situation where we're standing now. So a similar slide was already shown by Jane, but you see that in the European Union, we produce 58 million tons of plastic every year. And of this, nearly half of it is becoming waste. And out of this, only 30% is actually collected for recycling. And just because it's collected for recycling, it doesn't mean that it's really recycled, because the numbers show are different, of course, from industry to industry, but they lie between 8 and 10% that is actually being recycled. Then 39% is being incinerated, and 31% is being simply landfilled. But the problem is not only in the little amounts of plastic being recycled, but actually in the quality of the recycling and the resulting secondary plastic. As we heard before, there is, to recycle the plastic, there is a lot of processes being involved that change the properties of the plastic. And the secondary plastic that results from the recycling is not of the same quality as the virgin plastic. And if you look at it in economic terms, it is actually only 95% of the value of plastic or 95% of the value of plastic packaging is lost in economy every year, because you cannot get back to the same quality that you had before. And this one amounts to 105 billion euros every year. So that's a huge number that is lost in economic value. Another approach that I want to show, just to try to grip this number of how much economic value is lost, was presented by the Ocean Cleanup Project. Maybe you've heard of it, and Deloitte from Netherlands. And they made a huge effort to model and calculate the economic losses caused by marine plastic pollution, so river plastic, ocean plastic, and so on. And here you can see the economic costs associated with marine litter split by continental regions as it has been determined for 2018. And this one is split really focusing on the industry which is directly affected, so like tourism industry, fisheries, and aquatic industry. And here you can see how much cleanup costs and how much revenue losses result from simply plastic being discarded. So that's another viewpoint to look at the negative economic consequences of plastic pollution. This is another representation of the same problem, which shows a region-wide segregation of costs into cleanup and loss of economic value in marine tourism and fisheries and aquaculture. And here you can see what's interesting is that Asia has a significantly higher cost, average cost for cleanup than other countries, because it has a much higher emission of waste into the ocean, and of course a higher population density near coastal areas. And Europe, on the other hand, and North America have the highest average loss to economic value out of this plastic pollution. Another study that has also been published by the Marine Pollution Bulletin, it recently reported that the plastic pollution in the world's oceans cost the society up to $2.5 trillion per year, because it also counted in all the, not only the consequences for the marine tourism, fishery, and aquaculture industry, but also other social and industrial impacts. And according to this study, it says that every ton that ends up in the ocean, every ton of plastic that ends up in the ocean costs $33,000 per ton in reduced environmental value. And the problem is it comes back to the fact that actually there is no market for this plastic, and there is no use for this plastic and no applications. So the question is now, how do we get a value back into the plastic that is being discarded, or the plastic that has no use at the end of its lifetime? And how can you make this waste that becomes plastic pollution actually a valuable resource? And this is where circular economy comes in handy, because when waste is supposed to become a resource, it is necessary to create applications and markets for this waste. And how this can be done, particularly now in context with the marine litter, I want to show based on the company called OceanWorks, which created a network of suppliers that actually collect plastic from the oceans and supply the company, which then uses this collected waste plastic, segregates it, or already has it segregated by the suppliers, and then compounds it together with virgin plastic. And the idea behind this is that it gives this plastic pollution and the waste that is floating around in the oceans a new life and a new value. So suddenly it's not a waste, it's a resource. And the interesting thing here is, for instance, if you look at this TPE blend, they have, of course, like basic data sheet, which I don't show here, but like basic properties, technical data sheet, and so on. But what they use also as a marketing tool is to show the source type and the source continent. So that's an interesting way to actually put back the value into a material that has been considered as waste and as a pollutant in the ocean, and then even marketed in a way that it makes a profitable business model for this company. And I'm sure this is something that's gonna, especially if you go back to the picture that I showed in the beginning, where you see the different emission ratios into the ocean shown by the different continents. It's gonna have an impact probably in the near future to see where does my recycled content to my compound come from, because it's going to of course also determine the quality of this content. But that's a textbook example basically of applying one of the key principles of circular economic thinking. Make this waste basically a resource, or use it as a nutrient for a new service or a new product. And I don't want to dive into details regarding circular economic principles, but just wanted to present that treating waste as a resource for a new material or a new process can actually recreate this economic value and enhance this economic value when one considers the entire life cycle of a product. So for the plastic pollution, we're basically around these two on the left side. So we're basically failing to realize that we waste resources that have been used to produce the plastic, and we waste resources in terms of material resources from the product itself. So this is a value that can be redefined or regained when we consider actually these four aspects of the product life cycle. And these aspects are design and sourcing, end of use recycling, product use, reverse logistics. They are very closely related to the product design. And that's how circular product design comes into play, and this is something that shows the power of the circular design principles on applying them and considering the entire life cycle. So for now, we all know this linear economic model. So this was the standard for the last couple of decades. We mine the products, the resources. We just gain the resources through mining, for instance, or crude oil and stuff like this, and then they are being transported to some kind of manufacturer, compounder, who is doing some semi-finished goods out of it, or product parts. Then the product manufacturer is manufacturing a product, and then it goes to the product provider, and then you have as a user a certain function that you use, and basically afterwards it simply loses all the value and all the energy and resources that have been put into it. Simply loses at this stage, and this is the stage where the product, if it's made out of plastic, becomes can have a huge potential to increase the plastic pollution. So now that's how most of the products today have been designed. And now applying circular economy principles to product design aims actually to design products which maintain the value in a way that they can be used in one of these cycles. So it doesn't matter if it's simply the end, if it's a component of a product, or if it's a material component that is part of the discarded product. The idea is to really think about which materials can I use, and how do I put them together so that in the end I can have, at any stage of the product life cycle, I can have a value in these materials. And on a material level, these design principles already instigate which type of materials are suitable in order to close these cycles. And how that works, and that recycling is not the only way how to do design products or how to make circular products, I want to show with this example here, because it actually shows that if you apply these circular economy principles in product design, there is no other way than making a biodegradable fastener. That's a company, well, chemical company, but they're doing fasteners also, and these are those tag fasteners which you use, which you know from your clothing, price tags and so on. And if you now are the product designer and think about the material to use for these fasteners, if you apply circular design principles, you will have to ask the questions, is there a recycling stream for this product? What's going to happen after the people use it? Is there a recycling stream? Is there a market demand? Can it be a nutrient for another product? So imagine approximately 80 billion pieces of garment are being produced every year, and at least 1 or 2 fasteners are used for each of these pieces. So you as a product designer, you have to imagine that you're going to throw out 80 billion pieces of plastic every year on the market, and you know, because it's such a small and useless product in the end, that you will never be able to achieve a high recycling rate. So then what are you doing? So imagine you even wanted to recycle them. There is no other way than finding solutions that are biodegradable. And this is the idea behind this fastener, or behind the product concept of this fastener, was basically, since there is no recycling facility and recycling stream and possibility and market behind it, because it's simply too small, the circular design principle provided right away the answer that the material choice has to be a biodegradable one. There is no other way. And so that's how they did it. So basically, they add some additives which help the enzymatic degradation in an aqueous solution, and then it degrades in 28 days. And the message is basically that applying these circular design principles can help us to define and actually quantify and assess the value of the materials, the plastic materials that we use for the product. And this can be a response to plastic pollution if we divert from the linear thinking and start thinking in these circular terms, because only then it will be possible to assess this value and quantify this value. And it will be difficult to discard the plastic in the end as waste, because of course no one likes to trash money. So the circular economic consideration can play an important role in fighting against plastic pollution by simply assessing different values and scenarios of plastic waste, and simultaneously, of course, creating innovative solutions that create applications or new markets, as you've seen with ocean works. And eventually, the material becomes well, has a value like a capital value, and it's going to be difficult to discard it. The only other option that is that left is what you've seen with the fastener, is to make the plastic biodegradable, and to to drive this kind of thinking. Of course, you might need some regulatory help and some regulatory actions that would impose regulations, taxes, or penalties for producing plastics that are neither biodegradable nor recyclable. And I think this is also what is important, what we heard in the talk before, that it will definitely lead to a reduction in the different plastics that we use, but it would also increase the value of the material that we're dealing with. So until now, these markets in circular pathways are quite non-existent. So the thinking is there is already a couple of solutions, but until now we still have an economic problem. And simply because conventional plastic is so well established, it's cheap, the economies of scale for new innovative solutions are rather slow. And of course, there are quality and durability issues with bio-based plastic and recycled plastics. There is also no clear strategy on how you would compete with food crops when switching, for example, to bio-based plastics. But anyways, I think that's referring to the beginning of my talk. It just gives you a new perspective and shows the complexity and how important it is to have this systemic view on the whole problem. And that it's a profitable business model in the end, which shows that there is an economic system that works for the companies is something that I want to show in the last two examples before I finish. This is one which is an interesting combination of resource usage, because it's kind of partially closing the loop. So it's not completely circular, but it's a way on actually injecting this value back into a raw material or a waste material that has a lower value or no value. So the company Eastman developed a process for their Treva polymer line, where they use wood pulp, so a bio-based waste resource, and they give it a new value because they use it as a filler for a plastic that they are making using a process which yields syngas out of difficult to recycle plastics, so like category 47. So these plastics that have a very low value because they are difficult to recycle and they have a small market and expensive to recycle and so on. These plastics regain the value because they can be, in an innovative process, they can be converted into a gas that can be used to synthesize together with this cellulose fiber a new type of plastic that can be used as just the same type as virgin plastic. And that's something interesting because it combines, you know, the bio-based plastic synthesis and bio content of increasing a bio content that reduces the fossil fuel input, and on the other hand gives value to a material that is a low value or even waste material. Another interesting company that I wanted to mention in this aspect is LimnoPlast. That's a company which is now Nestle invested heavily in them because they patented an additive for plastic degradation that basically is like a ticking time bomb. So they put the additive into any type of polymer, and then when the polymer comes into contact with water, it degrades. It's not like it degrades instantly because it still needs like 15 years or something, but they compare it to the fact that normal plastic would biodegrade in 1,500 years, and this one would degrade in only 15 years, but only if discarded into water, because the interesting thing about this one is they introduce this biodegradability, but still, because it can be used for any type of plastic, still keep the recyclability. And that's another way of, you know, putting value or using the circular principles to actually find solutions that could reduce the plastic pollution problem. So what's the conclusion? I don't know if I cannot see Christoph anyway. Maybe he already showed up that I have to finish. But I hope I could show that some of the circular approaches and especially circular product design concepts can create economic opportunities that in some way can make plastic pollution feel like a waste of capital. But we're still at the beginning, and virgin plastic is still so cheap that it simply costs much more to take this extra mile of circularity than simply purchasing virgin materials. And that's definitely an economic problem. So in that sense, the take-home message for today would be, especially now in light of climate change, environmental concerns, the material choices that we make every day have to be simply taken more consciously. And this already starts the redefinition of the value of the materials that we use, especially in the polymer world. So now when fighting against climate change, it is the most important thing to remember that basically every of these material choices will have a much higher impact than they had decades ago. And since those material choices are governed still by the economic value of an economic system that is established in a way, we need to rethink the economic system and maybe look into systems that actually drive better material choices. And for this, circular economy principles may definitely provide a good framework. So in that sense, thank you for your attention, and I'll be looking forward to your questions.